In 1a, I want to solve this inequality. X minus 3y is less than or equal to 2. So the equals refers to the line. It's solid because we're including it in our answer, and we have to decide which side of this line do we choose. Again, 0, 0 is a pretty obvious choice. Let's try it out. I'm going to put 0 in place of both x and y in my equation and simplify it. So that's 0 minus 3 times 0. Is that less than or equal to negative 2? Is this a true statement? On the left we get 0, on the right we get negative 2, and this is false. That means this point does not work, and therefore I don't want to choose this side of the line. It has to be this side of the line that works. To see why, I'm going to choose a point on this side and plug it into the inequality, and hopefully it's a true statement. I'm going to try the point, how about 1, 6? So I'm going to try this point here. You could use any point you want, but I'm just trying this one out. That's 1 for x and 6 for y. In my inequality, that's 1 minus 3 times 6. Is that less than or equal to negative 2? Is this a true statement? So that's 1 minus 18. Is that less than or equal to negative 2? That's negative 17. It's less than or equal to negative 2. This is true. That means I want to use this side of my line because this point worked. Let's try this again in part B. Here I have y is greater than 4. Now there's no equal sign, which is why we're not including the line itself. Here it's represented by a dashed line. 0, 0 is available, so again, I say we try that. I'm going to put 0, 0 into the inequality y is greater than 4. Now, there's no x's. That means this value just doesn't go anywhere. This one does, though. I'm going to put 0 in place of y, and we're going to see if this is a true statement. 0 for y. Is that greater than 4? And the answer is no, that's false. And said another way, that means I'm not going to use this point. I'm not going to use any of these points. Let's try just a point to see that works. How about the point negative 6, 8, which is right here. Again, you could use any point that you'd like. I'm going to try this one out. So that is negative 6, 8. In the inequality, the negative 6 goes nowhere. The 8 goes in place of y, and I'm asking, is it greater than 4? And yeah, this is true. That means all of these points above the line work. In 2a, I want to solve this equation for x. You could multiply both sides by 10 to eliminate the decimals, but I'm simply going to approach this problem by subtracting 0.4x from both sides of my equation as my first step. 0.5 minus 0.4 is simply 0.1x. Plus 1.5 is equal to negative 0.5. I'm now going to subtract 1.5 from both sides, and I get 0.1x is equal to, okay, negative 0.5 minus 1.5 is negative 2, and to get my final answer, I'm going to divide both sides by 0.1. This will increase my value on the right by a factor of 10, making the final answer negative 20. For part B, I'm going to take my original equation and I want to cancel the numbers that are in front of the x, this fraction. And a trick that works really nicely in one step is to multiply both sides by the reciprocal of this fraction. So I'm going to write it like this. On the left, I'm multiplying by 3 over 2, but I have to make sure I do this on the right as well. And just to make sure we're comparing fractions, I'll put it as 18 over 1. On the left, the 3's cancel as well as the 2's to give me just 1 in front of x, so I'll just put x. And on the right, 2 goes into 18 9 times. This is really just 3 times 9, and that's equal to 27. In part C, I have to start this by removing the parentheses, meaning I have to distribute the 2 as well as this negative, which is really a negative 1 in front of the parentheses. This changes my equation to 2 minus 2x plus 3 is equal to negative x minus 3. On the left side, the negative 2x combines with nothing, but I have 2 plus 3, which is equal to 5. And on the right, negative x minus 3 can't be simplified any further. I think what I'm going to do is add 2x to both sides. This gives me 5 is equal to negative x plus 2x is x minus 3. I'll now add 3 to both sides, give me that 8 is equal to x, and this is my final answer. In part D, I'm going to take the approach of canceling the denominators by multiplying both sides by the least common denominator. So that's really a 1 over 1. So for my 3 fractions, it's 2, 1, and 4, meaning that 4 is the least common denominator. I'm going to multiply this to every single fraction. I'll write it as 4 over 1 is being multiplied to x plus 1 over 2. Then I have 4 over 1 being multiplied to 1 over 1. This is pretty redundant. You could have just put 4. That would be completely okay. And on the other side of my equation, I have 4 over 1 being multiplied to 3 over 4. It should be that all the denominators cancel to 1. 2 goes into 4 twice. I'm going to be very careful to put parentheses here because that 2, it's multiplied to both the x and the 1. In the second part, 4 over 1 and 1 over 1, I can't cancel anything. The denominators are already 1. But on the right side of my equation, 4 goes into 4 once. I'm left with 2 times x plus 1 with parentheses, then plus 4 is equal to 3. To solve this problem, I'm going to start by distributing the 2. This gives me 2x plus 2 plus 4 is equal to 3. If I combine like terms on the left, I get 2x plus 6 is equal to 3. I'm going to subtract 6 from both sides, so I get 2x is equal to negative 3. And after dividing both sides by 2, I'll put my answer over here. I get that x is equal to negative 3 halves. In the next question, I'd like to graph this line by using an x and a y-intercept. And this is the x-axis. I'm going to start by finding the x-intercept. To do this, I'm going to let y equal 0 in the original equation of 3x minus y is equal to 6. That is, in place of y, I'm going to just put 0. This is a lot of writing because it makes the equation simplify very quickly to 3x is equal to 6. I'd actually be okay if you started right here. To solve for x, you're going to divide both sides by 3, and that gives you that x is equal to 2. This is the point 2 for x and 0 for y. That is my x-intercept, which is located right here. Now to find the y-intercept, I'm going to let x equal 0 in my original equation. So the original equation is 3x minus y is equal to 6. So putting 0 in place of x simplifies the equation to negative y is equal to 6. And after dividing both sides by the negative 1 that's technically in front of the y, I get that y is equal to negative 6. This means my y-intercept is 0 for x and negative 6 for y, which is located right here. The equation of the line is the thing that goes between these 2 points, and that's a pretty decent sketch of the graph. Now, what is the slope, which we define to be the rise over the run? if you start at this point, how far do you rise and then go over to get to our second point? Well, the rise, since it's going up, will definitely be a positive number. Since we're starting at -6 and we arrive at 0, we've gone up a total of 6 places. The run is how far you go over, which is 2. And you could leave this as 6 over 2, I suppose, but it's really 3 over 1, or just 3. 3 is the slope of this line. In 4a, I'm going to start this by asking, is the answer going to have a positive or negative in front of it? We're multiplying 3 negatives together, so I know the entire answer is going to be negative. I'll start there just to get it out of the way. The next thing is, well, what about just the numbers themselves? There's only this 5, so actually it's going to be -5 that is in front. I'll then compare the x's. We have an x cubed times technically an x to the first, and then we have a y times a y times a y, and those are all to the first power as well. We have a rule that says we can simply add our exponents together for like bases. There's a total of 4 x's and a total of 3 y's, making this the final answer. For part B, I'm going to put a 1 on that 2 because it's technically 2 to the first power. And we have a property that says this exponent gets multiplied to those two values. So this will be 2 to the -2 and the y to the +8. That's 2 to the -2. Again, this comes from multiplying -2 and 1 together, followed by y to the +8. That 8 comes from the product of -2 and -4. Anything that has a negative exponent we've been putting into a denominator. This is really y to the 8 over 2 squared. And if you square 2, you get 4, making this my final answer. For part C, I'm going to break this up into 3 fractions. And start by looking at 125 over 5. Well, 5 goes into 125 25 times. And for the remaining pieces, I have a property of exponents that says, well, if we divide like bases, we subtract the exponents. So you have 7 minus 7, as well as 10 minus 2. It looks like the answer is 25 x to the 0, y to the 8. And one thing to point out is, if x is not 0, we can simplify this to 25 y to the 8, which will be the final answer for this problem. And the reason for this is, here, a non-zero number to the power of 0 we defined to be 1. And in part D, I'll use the same property that we used in part C, where, okay, I have x to the -3 over x to the -2 times y to the -4 over y to the -5, and I'm simply going to subtract the exponents. That's -3 minus a -2, and then y to the -4 minus a -5. I'll rewrite all of this as, that's really x to the -3 plus 2, and y to the -4 plus 5. That is x to the -1 and y to the first. If we have a negative exponent, we'll move that to the denominator. And what? And technically, if there's a 1, you don't have to write that either, so that's y over x, and that is the final answer. Let's use scientific notation to multiply these two numbers together. I'll start by converting this to, well, it's really going to be 7, and we're moving the decimal 1, 2, 3, 4, 5 places. That is 7 times 10 to the 5th, except since it's becoming smaller, I'll put -5. Now we have 8 times 10 to the power of 3, 6, 9, 12. I'm now going to multiply the like parts together. 7 times 8 is simply 56. But here, if you have 10 to the negative 5 times 10 to the 12, the bases are the same, so I can simply just add those two together. That's negative 5 plus 12 is positive 7. I think I'll make note of that. So this thing here came from adding those two things together. This is not quite the answer yet, so I'm just going to change it so it looks more like scientific notation. 56 times 10 to the 7th. And, okay, the problem is I really don't want to use 56. I want to use 5.6, a number that's between 1 and 10. So we just made 56 smaller by a factor of 10. To make sure these two things are equal, I have to increase the 7 by 1 to 8. So here all I did was add 1 to the exponent, making this my final answer. And in the last question, a student's grade is based on 4 quizzes and a final exam. The final exam counts twice as much as a quiz. Okay, here we're given the 4 quiz grades. Okay, and the question is, well, what does the student need to get on their last exam, the final exam, in order to get a 75 in the class? I'm going to let X equal the grade on the final. And since we're talking about an average, here's how it works. We're going to add up their quiz grades, but you also have to add in what they get on the final before you start dividing by how many things that you have. If the final counts twice as much as a quiz, that means you're adding it in twice to our average. So when you divide, you have 4, technically 6 things that you're dividing by because you're putting the final in 2 times. Now, we want this to equal a 75. I mean, technically, you could say greater than or equal to, but I'm going to leave it at this. I want to solve this equation for X. What I'm going to do is add these numbers together, replace this with 2x to simplify my equation. All right, so I type this into my calculator, and I get 285 plus 2x over 6 is equal to 75. I will now multiply both sides by 6 to cancel the denominator on the left. I get 285 plus 2x is equal to the product of 75 and 6, which is 450. I don't need my denominators of 1. I will now subtract 285 from both sides. That gives me 2x is equal to, and if we take 450 and subtract 285, I get 165. I'm running out of room a little bit, so I'll put that over here. 2x is equal to 165. I will now divide both sides by 2 to get my final answer of 82.5%. This is the grade the student needs to get on their final exam in order to get exactly a 75 in the class. And therefore, anything that they do better on the final will only increase their average, which is why I left this as an equal sign instead of a, let's say, greater than or equal to. And that is it for this problem.